Electricity powers our world. Every time you flip a switch or charge your phone, you're tapping into an invisible force. But how exactly is electricity produced? And how does it travel from a power plant to your home? In this video, we'll break down the fascinating process of electricity production, the different types, and how it's transferred across long distances. Electricity is the flow of electrons, tiny particles with a negative charge that move through conductors like wires. It's a form of energy that powers everything from your home to entire cities. But how do we produce it? Electricity is produced in power plants through several methods. Let's explore the main types. 1. Thermal power generation. This is one of the most common ways to generate electricity. It involves burning fossil fuels like coal, natural gas, or oil. The fuel burns to produce heat, which turns water into steam. The steam spins a turbine, connected to a generator, producing electricity. 2. Nuclear power generation. In nuclear power plants, atoms of uranium are split in a process called fission, releasing a huge amount of heat. This heat is used to generate steam, which, just like in thermal power plants, spins a turbine and generates electricity. 3. Hydropower generation. Hydropower uses water flow to generate electricity. Dams are built on rivers, and the water pressure from a reservoir turns a turbine, which is connected to a generator. 4. Wind power. Wind turbines use the wind's kinetic energy to spin large blades attached to a generator. The faster the wind blows, the more electricity is produced. 5. Solar power. Solar panels capture sunlight and convert it directly into electricity using photovoltaic cells. These cells contain materials that absorb sunlight and release electrons, creating an electrical current. And finally, 6. Geothermal power. Geothermal plants use heat from beneath the Earth's surface. Hot steam or water from deep underground is used to spin turbines connected to generators. Each of these methods has its pros and cons, but they all rely on turbines and generators to create the electricity we use every day. Once electricity is generated, it's important to understand that there are two main types: direct current, or DC, and alternating current, or AC, DC, or direct current. In DC, electrons flow in one direction, from the negative to the positive side. This is the kind of electricity produced by batteries or solar panels. AC, or alternating current. In AC, the direction of electron flow alternates back and forth. AC is the type of electricity used in most homes and businesses because it's easier to transmit over long distances. After electricity is generated, it needs to be transported to homes, businesses, and industries. But here's the challenge. Electricity is best transmitted over high voltages, but we can't use that high voltage in our homes. So how is it done? Step 1. Step-up transformers. The electricity is sent from the power plant to a step-up transformer. Here, the voltage is increased to make the electricity travel more efficiently over long distances. Step 2. Transmission lines. The high-voltage electricity travels along transmission lines, which are the tall power lines you often see stretching across the landscape. These lines carry electricity over hundreds, even thousands of miles. Step 3. Step-down transformers. Once the electricity reaches a local area, it's too powerful for regular use, so it passes through step-down transformers, which lower the voltage to a safe level. Step 4. Distribution lines. After being stepped down, the electricity travels through distribution lines, which bring it to your neighborhood. These are the lower, often shorter power lines that you see running through your streets. Step 5. Final step. Into your home. Finally, the electricity enters your home, ready to power everything from your lights to your refrigerator. All of this is managed through something called a power grid, a network of power plants, transformers, and transmission lines that work together to deliver electricity. But as technology advances, we're moving towards smart grids, which use digital technology to monitor and manage electricity flow in real time. This helps prevent outages, improve energy efficiency, and allow for better integration of renewable energy sources like wind and solar. Once the electricity reaches your home, it powers almost everything you use daily. Your lights, heating and cooling systems, computers, kitchen appliances, and even your phone chargers. It's a vital part of our daily life, but we often take it for granted. Electricity is a powerful force that makes modern life possible. As we look to the future, the focus is on making electricity cleaner and more sustainable. By using more renewable sources like solar, wind, and hydroelectric power, and by creating smart grids to improve efficiency. So, next time you flip a light switch or charge your phone, remember the journey your electricity has taken, from the power plant to your home, through transmission lines, transformers, and more. Understanding how it's produced and transferred can help us appreciate this invisible yet essential energy. If you enjoyed this deep dive into how electricity is produced and transferred, don't forget to like, share, and subscribe for more exciting videos. Have questions? Drop them in the comments below.